again. Okay, so here again, this is a matched pair problem because the data is matched up. As we read it, negative ion sports bracelet claims to increase athletic performance. Test the bracelet, 8 runners asked to run a mile. Their times are compared to their times without it. So in other words, this is runner number 1 here with no bracelet and with the bracelet. This is runner number 2. No bracelet with the bracelet, etc. So these are matched pairs, right? It isn't like they just took 8 runners and they you know, the other way they could have done it. They could have done it like 10.2 independent in two independent samples groups, is they could have just said, hey, let's just give 8 runners the bracelet, runners, and 8 different runners. 8 different runners, so they'll get the bracelet, and 8 different runners, no bracelet. And then we'll just take the average time for these runners and the average time for those runners, the ones that have the bracelet and the ones that have no bracelet, and we'll compare them. That could work. That's probably not as good of way, is it? You can feel that would not be as statistically strong of a way to test the bracelet. It's better to test it on the very same runners, which is what we're doing. So I'm just showing you the difference in how you can set up statistical studies. You could do it like what we did in 10.2, 2 independent samples. You can just give 8 runners the bracelet, 8 totally different runners, have them run no bracelet, just take the average time for these people and the average time for those people. And if the people with the bracelet did better, maybe the bracelet's working. Well, yeah, there's a lot of problems with that, isn't there? These could have just been better runners, et cetera, et cetera. It's better to do it with the same people, right? This is the same runner without the bracelet and with the bracelet, without the bracelet and with the bracelet, without the bracelet and with same runners. So that's matched pairs. So these are all matched up. So that's how we're doing this problem, is with matched pairs, not 2 independent groups. That's a better, statistically stronger way. You could, if you want to learn if the bracelet's working, have the same person run with and without the bracelet. Okay. Well, here's what's really important and what I messed up on the first time. You've really got to watch their question more closely than I did. Notice it says, estimate the average difference in mile run times when wearing the bracelet. It says with minus without. There it is. You've really got to, I included, have to pay attention. The width has got to be L1 and the without is L2. So this is L1 and this is L2. They're trying to trick us. They did trick me with the table. They're reversing it. You see that? So it's all about what they ask you to do here, not what the table originally shows. They're saying, please put the width first minus the without. So the width has to be the L1. The width is the L1. And the right there, and the no bracelet, the without, is L2. All right, so that's what you have to do. So let's hit stat. You're already on the edit menu. Whoops, kind of funny looking. And hit enter. And then go to the top of L1, hit clear and enter. Top of L2, clear and enter. Put the right column down L1. The left column down L2. You got to reverse those because they said right here with minus without. We got to do their order. And then when you're done, you hit second and the mode quit button to get out of that L1, L2 table. And then you know what we're going to do, right? According to the exam 2 notes, which are somewhere right here, the exam 2 notes tell us put data in L1 and L2, then second 1 minus second 2, L1 minus L2 stored into second 3, L3. Then we go to t-test or t-interval. This is not a hypothesis test. Ours is a confidence interval. Go to t-interval, data, and then make sure L3 is your list. So that's what we're going to need to do. So let's do it. So we're going to hit second 1 minus second 2 stored into second 3 enter. And that'll take L1 minus L2 stored into L3, which is going to be the with bracelet, because that's where we put L1, minus the no bracelet L2, like they said, with minus without. So that'll do it right. Once you do all that and then hit the enter button, you'll get a confidence interval, and then you have to round it to 2 places. And so when I rounded mine, I got, what did I get? -0.19, comma 0.17. I think. Let me double check real quick on my calculator. All right. Oh, and I didn't tell you the rest of the buttons to push, did I? So we have to, so after you do that, you have to press stat, go over to tests, go down to, so what are we going to do? We're going to do number 8, which is T interval, because this is a confidence interval, not a hypothesis test. And it's T interval, not 2 sample. Notice it's not 2 sample. Go back to the notes, right? It's just T interval. It's not 2 sample, and you got to make this L3. That's the key thing there. It's not 2 sample because all of our data is now in L3. We just have that one group of data, L3. So you got to choose a data, because we put in data, and hit enter. And then you'll have your information. You'll have list, which L3. You got to put L3 there. Second 3. It's got to be L3. Frequency is always 1. And the C level for me on this one, 85%. So there we go. Calculate. And yep, I get this interval right here, rounded to 2 places. And then what does that mean? So to draw the conclusion to a confidence interval, what do we always do? Well, that's also down here in the notes. And I'm showing you in the notes that when you get 2 negatives, it means, you can follow this chart. 2 negatives mean mu1's, the first one's lower. 2 positives means the first one's higher. 1 negative, 1 positive, some negative, some positive means blah, blah, blah. It means 0 is in the interval, right? Between a negative and a positive, 0 is in there, which means they might equal 0. The difference might be 0, which means they might be equal to each other. If the difference is 0, they're equal to each other. So we have no confidence that they're different. They might be the same. So that's how you conclude a confidence interval. Let's go back and see what's going on with that. What did we get? We got some negative, some positive, didn't we? So negative 0.19, positive 0.17. We got some negative, some positive, which means they, what were the words they used? We have no confidence that they're different. They might be the same. No confidence. No confidence they are different. Might be the same. So we say inconclusive. Inconclusive. We have no confidence that these are different. We have no confidence that the bracelet makes a difference. No confidence. It might be the same. These runners might be doing the same with and without the bracelet. At the 85% level, we do not have 85% confidence that there's a difference, that the bracelets really make a difference. We have no confidence. It's inconclusive. And I want to make sure that you see why that's the case, because not just from the notes, but do you see logically? Remember, we're subtracting two things. We're taking, L1 minus L2 or mu1 minus mu2, whatever you want to call it. If you subtract two things and get a positive answer, do you know what that means? That'd be like 10 minus 7 comes out positive. The first number, the first is bigger, right? That's what that means when you subtract two things and get a positive answer. That means the first mu1 is bigger. Whereas, what if you subtract two things and get a negative answer? What does that mean? Well, that'd be like 7 minus 10 comes out negative 3, right? That means the first is smaller, right? That means the first mu1 is smaller. So that's why it says these things, right? All negative means the first is smaller than the second. Whereas if you get all positive, the first is bigger than the second. But if you get a mix, it could go either way. That's what we're saying, right? We got a mix here. We got, our answer, we're saying that our answer is somewhere between negative and positive. In other words, what we're saying is let me try to be really clear here. We are 85% confident that mu1 minus mu2 equals an answer between negative 0.19 and positive 0.17. So in other words, if you gave a number line right here, so I'm getting kind of running out of room here, and you're saying we're going from negative 0.19 to positive 0.17. Well, here's 0 about right there, right? So you're saying that your difference is somewhere between negative 0.19 and positive 0.17. So there's negative territory there and there's positive territory there, right? If you're saying you're 85% confident that your difference is between negative and positive, that means your difference could be some negative number. It could be some positive number. We don't know. We don't know if the difference is positive and thus the first number is bigger, or the difference is negative and thus the first number is smaller. We just don't know. We have no confidence that there's really a difference. Zero's in that interval. The difference could be 0. And if the difference is 0, they're equal. They might be, that's why we're saying they might be the same. We're not confident they're different. That's why we draw that conclusion. So watch out. The main trick here, you've got to watch these words or it'll all get messed up. Right here. You've got to watch the order in which they say they wanted with, minus, without. So you got to make the one they want first, L1. So I had to make the right column L1. So watch those words carefully.